Thank you, Eric. Thanks, everyone. So yeah, we'll talk a little bit about our journey with DDMRP, with DBR Plus, where we're starting to go with getting DD&SOP brought into the company, and how it all fits with our environment, with the results that we've had as well. Okay, so we'll do a little bit of an overview as to who we are, what the company does, what was the problem that we had that motivated us to go in this direction, what the solution was, and as we got through it, we'll go through the results and our learnings. So first of all, an overview of the company. We're a family-owned company based out of Vancouver, BC. The company was founded in Vancouver about 20-some years ago by Dr. Alan Eves. We've been self-funded from the beginning. All our products are developed in-house, and we build products that help with cancer research. So there's two types of product lines that we have, and they've been growing 20% year over year since founding in 1994. We're going to do $230 million this year, and so far we're on plan. So over the course of the company, we're $1.2 billion of cumulative revenue. This is our portfolio of products. There's about 4,000 of them. As I was saying, the majority of them are either cell separation product lines, where you can isolate certain types of items from cells, or you can also do media to cultivate things like a particular type of cells, or we'll take stem cells and we'll grow them in an undifferentiated state and keep them in that condition. And this is used for research purposes for the most part. So here's our global footprint. We have offices in North America, Europe, and Asia, Australia, and Singapore. And all of these are distribution facilities. All our manufacturing is in North America. One of our key goals that drove us in this direction is we always want to be able to serve our customers with next-day service. So we have this wildly important goal, which is Drive for 95. And that means that 95% of all customer order lines ship the next day. So at 2016, we were getting there, but we weren't quite where we wanted to be. We were at 88.6%. And there were a variety of factors that were affecting this. So much of what we do is very specialized. Some of them have very long lead times. Some of it is hard to make. There's uncertainties, new products. So all kinds of things were affecting us, and we need a better way to do it. So how are we going to do this? Here's a little bit of where variability was coming from. So we have global sourcing and demand, variable product shelf life, things expire. There's complexity and customization in some cases that comes into the picture, increasing product variety and changes in mix, biological variability from batch to batch, which is a big challenge for us, a lot of single source and long lead time parts. One of our bombs has a total cumulative lead time of 520 days, to give you an idea. Short customer tolerance time, so people operate on grants. They need to perform their experiments. They want things to be consistent. They need the products now. Change in demand variability, things take off unpredictably. Pressure for linear inventories, of course. And so how are we going to solve it? So the solution was not working harder. That just gives you a headache, right? I don't know if you guys have seen this animation before. So we're looking at putting in place a demand-driven adaptive enterprise, and we borrowed the DDMRP image and using it sort of for a core of our presentation to walk you through the process that we followed. So if I can find the pointer here. So we have the DDOM side, so DDMRP, demand-driven scheduling execution, and over here we have DD&SOP. And to a degree, we've done this piece and are starting to work on tactical reconciliation and exploring the projection. So we'll walk you through that. The first step was implementing DDMRP, and we'll jump into how we did this. So we wanted to get inventory under control, and Geoffrey can walk you through that.
Which ones?
The bottom one.
So about DDMRP, we started in 2014. And the first step for us was to know where to start and with what type of material to start. So this is the picture of STEMCELL. So everything is made in North America, and almost everything is made in Canada. And we have some distribution centers in the US, Europe, and Asia Pacific. And our first decision was to start with making sure that our suppliers and raw materials were safe. So we started with procurement, and then we went on the other side and started working with finished goods, and mostly at the distribution center side, as it's usually easier, the lead time is consistent. You have one shipment per week from head office to these distribution centers, and with lower inventory, so that was easy to just put this on track. And then once the raw materials and finished goods were mastered, we focused on the most complex ones, which was in-house product and exploring the bill of materials and where to put buffers inside finished goods and intermediates. So just some key numbers for you. So we have 3 AirPlus instances at the moment. The biggest one is in North America, as we have lots of planning locations to manage, as we first have US and Canada, then we have a few CMOs, some 3PLs to manage, and some strategic locations too. And then we have Europe, where we had France until now, and recently, because of Brexit, we are now having 2 points of stock, so one in the UK and one in Europe for the rest of Europe. And Asia Pacific, where we have China, Australia, Singapore, and we started implementing some stock at the customer location, replenished by ourselves. So about our buffers, when we started looking at our variability and say what type of variability do we have per parts, and is the demand consistent or not? And as we can see, the variability was pretty high. And so from an AirPlus point of view, we build 9 dynamic buffer, and we just increase the rate zone slightly. So ideally, you're on this side where you have low variability, you're mastering, you have a good relationship with your supplier, your demand from the finished good is pretty consistent, or you don't have a lot of variability in manufacturing. And when it's not the case, you're slightly going this way, where you need a big, I would not say safety zone, but a big rate zone. So there was a gap to fill, and at first we were not sure if DDMRP was the right solution or not, so we had to test it. And so for this, we built a simulation Excel file tool, where we were basically able to extract the last year of demand day by day, and we were able to put our lead time, our variability, and everything, and just simulate with a dynamic buffer what would be the service level part by part, and what would be the inventory to hold in order to achieve this service level. So we can take one example. So on this part, so we are taking all these buffers, and we are starting with the lowest one, and we are putting a target. So I want to reach 95% for my service level, and as long as 95 is not achieved, we are increasing buffers until we are at 95. So in this case, the first one is not good enough. Like with this low buffer with a small rate zone, you would be at 94. So we are going to the next one. We would be at 96, so it's not good enough. With the next one, we are at 90. With the next one, you're at 94, so almost there. And on the next one, you're at 100, so the simulation stops. You know that you have a recommended buffer that can meet your target, and at the same time absorb all the variability in demand. And so you can choose your buffer based on this simulation. And it really worked well for us to reassure all the people in planning and procurement, knowing that, yeah, with this solution, you may have something that will be dynamically adjusted every day, and that will help you achieve your target. So with this, you're at least able to take an educated decision and to know, if I want to achieve a certain service level, here is the investment needed. So for some parts, it was an investment. For some other parts, it was savings compared to the min-max that we had with MRP in 2014 versus what we can have with a dynamic buffer today. And so we were able to close the gap and just make sure that DDMRP was right for us, that it was good enough for our business model, and that, yeah, it was fitted our needs. So we brought some quotes from another planning manager here, and yeah, she really liked to have a buy-in for them, and from the change management piece, like having this simulation and being able to prove with numbers and figures that, yes, this will achieve your goal, you will even be able to save some money in inventory. That was great for us. About dynamic adjustment, so we are refreshing AirPlus twice a day. So twice a day, all the planners and buyers are coming and they have a fresh workbench, new planning priorities, new alerts to check. And so twice a day we're updating everything from bill of materials, supply, demand, inventory, and all the UDFs and the part that we have. Daily we're updating the ADU. And on demand we can have some adjustment factors to plan for seasonality, or like recently we planned for Brexit, we planned for SAP implementation if we are closing manufacturing for a few days or anything else. So demand-driven planning at STEMCELL. So we now have some kind of daily routine plus monthly routine. And so what is expected from all the planners across the globe and all the buyers too is that first we want you to bring all your we want you to look at your AirPlus dashboard, look at what you need to do, and do this in this order, and finish the day with all your parts in the green from an available stock point of view. Then, if you still have some time, look at your alerts and start with putting some updates and notes on all the critical alerts, and then clean your over top of green parts and make sure that if one order was canceled, if you plan too much or whatever, just make sure to reduce something if you still can. And last, we have visible collaboration. So now we are bringing all the team together, and we have a buffer sizing remodel just to make sure that all your buffers are modeled correctly. We are still driving for 95 or more, and we want to look at, do we have too much? Maybe sometimes we have not enough. What needs to be resized and which criteria is used? And then we can change the buffer, make sure it's all remodeled correctly, and also challenge our lead time and make sure we can we decrease the lead time? Maybe the variability is decreased, maybe it's the lead time. So that's one field that we are monitoring closely too. From a service level perspective and inventory availability perspective, so we can see that there was a big jump. So as Juan said, we started at 86, 88, and in like a year or 18 months maybe, we quickly went from 86 to around 95, 96, and it has been stable since a year or two. And since we recently implemented DBR, we are guessing that we'll have another jump soon. And I think one of the biggest wins we recently have, I was invited in a sales management team, and the head of China was speaking about a big call for tender that they have. And the only difference that there was between us and our competitor was not around quality or price, but we won the call for tender because of service level. So the customer only chose us because he was like, yeah, if I'm choosing STEMCELL, I know that within the next 24, 48 hours, I will have my product. And with the other competitors, I have to wait a week or two. So if we focus on this specific here now, we have lots of metrics based on DDMRP results and service level. And it's easy for us to investigate where do we have some issues, what are the root cause, do we have to work on the DBR side, AirPlus side, manufacturing side, or just with top management. And so, for example, we recently experienced some capacity issues. We will talk more about it after in the case today. And so that's where we saw that some actions were needed, and we quickly implement them to go back on track in a few weeks all the time. So now Juan can take the rest for demand-driven scheduling.
Thanks, Geoffrey. So as you were seeing on the previous graph, and I'll just go back for a second, here we have, and we're tracking above our 95% target for inventory availability. And what that means is not just that it's shipped in time, but from an operations perspective is, did we have the inventory on the shelf when the customer placed the order? So we take out the distribution piece so that we can just evaluate our planning activities. And here we can see that we weren't able to meet the target for a specific product line. So what happened, right? And in this case, we were being late to the buffer, and we knew that it was because of capacity. So we needed to get that under tighter control, and that's when we started to bring the demand-driven scheduling piece. So jumping into that and the approach that we took to put this into place, our first step was to model our environment. And I'll give a very simple example here of one of our generic plasticware products. And the first thing is, like, what are the steps that are needed to make this product at a very coarse level? How do they interact with each other? Where do you go from your raw materials to your finished goods? And where in this sequence do you have the constraint? Or what is it that is going to gate and drive your scheduling? And in this case, it was this particular step, which is setting up and running the coder. And how much do we want to protect this so that it's always running and we can guarantee ourselves of continuous throughput and output, so flow, right? And here we have to talk about where we're going to place our buffer and how big it's going to be. So we went about defining all the resources in the DVR system, how much capacity they have. Is it going to be people? Is it going to be equipment? Is it going to be space? There's different varieties for different processes that we have. What are their calendars? How many hours are you going to assign? And this will be the core of our scheduling model. So we built it, we set it up, and we started to run it. And once we did that, we're able to actually start scheduling on a demand-driven basis, right? And every day we schedule based on R plus priority, so it's not scheduled by one thing anymore. It's scheduled based on the urgency. So does the buffer need it? Is the buffer at risk? Is it a customer order that is waiting for shipment? And we only schedule the things that we can build according to our model, so we don't over-release the shop floor. And we have a workable schedule that we can execute for. And every day we have a meeting where we review it, and Geoffrey can talk about that one. So there's the visible and collaborative execution piece, and here we go.
So what's really new here is that before implementing DBR and driving manufacturing from a demand management perspective, we had some silos. And back then I was still in France, and for example, when I was calling here to know when we will have this product, there was some black box like, yeah, it's in QC somewhere, yeah, it was manufactured, it will be available maybe next week. Like, there was a lot of uncertainty and no visibility at all for us. And so we were able to blow up all these silos and bring everyone as a manufacturing team. And so now every day, every morning, we have a quick stand-up 10 minutes meeting where we're able to have all these people you can see. So we have planners, schedulers, manufacturing, QC, and QA. And we're able to track. We have the buffer boards in DBR to say, okay, who is on time, who needs help, do we have to shift someone from a team to another to have some help? What is the status of a buffer in AirPlus? Can we link this to DBR? And do we have some backlog, or is it better and better or worse and worse? And so every day we can have this quick stand-up meeting to talk about a few urgency and say, yes, we have 200 work orders at the moment. We need to talk about 5 of them, and the rest is just regular flow and fine.
Okay, so what did we get when we put this into play? So we'll go for the first 30 days. And when we first put this into play, one of the things that we noticed right away was that we had, there's a QA release process where QA has to check the paperwork for every batch, make sure that everything was built according to our standard procedures, they used the right materials, that the right people signed off on all of the steps. And they used to take 7 days to do this. And there was a backlog that was accumulating on them, right? So they were a bit of they weren't really the constraint, but they were a bottleneck in the process because they didn't have enough resources. So we found out that that was the issue. We helped them prioritize things based on the actual priority from the buffers or from customer demand, and we staffed them appropriately. So that took 4 days out of our lead time. So all the parts that went through QA had an additional 4 days that were necessary just because there wasn't enough resources in there and the administrative processes that they had. So that was a big win for us. Then the next one is, it's one of those like, what's the right point to go live and how accurate do your routings have to be? And for us, we just focused on getting them close enough so that they would allow us to know we need to make this week. And then we let people in the shop floor operate within that time frame and make things as they see fit. So we didn't really have alignment of the daily tasks with DVR schedules, but we had a system that we could work with and get to a stable place from where we could remodel after that. So once we got to the first 30 days, we did another remodel, and we changed it by incorporating some additional steps in the routings to do the labor allocation. So it's very important for us when people are making products, who makes the products. We want to make sure that people get cross-trained. People are sometimes not necessarily trained by the process, but on the actual product that they're making. And we want to make sure that that cross-training goes on, right? So it's not really something that you can put in your model and schedule and say it's somebody's turn to make a product. But we could put something in place where the supervisor could assign the specific resources to the work being done that week. So once we did that, we got better alignment between the DVR schedule and the actual manufacturing work, and it allowed us to shorten our release horizon. Before this, we used to release 2 weeks of work at a time, so that was 14 days of lead time for every product. Once we took that out, there's another 11 days that got taken off the lead time. And the results of that, as you can see here, is before DVR, this is a buffer. And of course, this example is going to vary based on the lead time that you have. I took 60-day, which is something that is reasonably common for us. So before, this is our base buffer. Once we took out those 4 days from QA, the buffer can shrink 7% and get the same service level. After the first remodel, there's a 25% reduction on your average stock. So this was pretty significant for us and relatively easy to gain, right? And this isn't even a place where we're starting to change our manufacturing processes or how we make our product. Like, there's no real physical change to how things are happening in the shop floor or what people are doing. It's just better priorities, a better way to plan, and the ability to release things more nearer to when you need them. So we don't have to be going out and guessing for 14 days and sticking to those priorities. Now we can just go 3 days at a time. So that was a big win for us. The next one is the tactical reconciliation piece. And just this should be green, but I think we have some sort of saturation thing with the projector. But I'll talk a little bit about this too. So here we have all the metrics that we measure. And we start with making sure that we have the right lead times from the suppliers, that we have the right demand, and we filter out some signals that sometimes may be outliers and we don't want to use. Make sure our planning parameters are maintained. We get our raw materials on time. The raw materials buffers are working properly. We manufacture according to our plan. And then there's our inventory availability and ultimately the drive to 95, right? So we focus on our outliers on our buffers as well as on our delivery to target date on the schedule. And this comes from R Plus and DVR. And again, driving to 95. So here's an example of a particular product. And what you'll see here is we're keeping up with demand, but the buffer it's not really on its target zone. So it's on the red zone pretty consistently. We made an adjustment to the lead time, increased the capacity, and started to fill this buffer. So we're feeling pretty good. And then we ran into some demand spikes. The buffer got overwhelmed, and we were in a back order situation. You can't really see it here for the granularity on the chart, but there were definitely some stockouts in place at that time. And what we did is, how do we increase the capacity? So we took this product line and used it as an example of how we could develop a process to get the modeling team to start exploiting the constraints. So not only changing how we schedule and how we have our administrative processes to manage this information, but actually how we utilize our equipment and our capacity. So here's the process that we followed. And what you see here are the steps in the routing. And this is expressed in output of units per hour. So you can't see what the description of the steps are, but you can see how many units per hour are produced. And the black line on the top is the percent of utilization of that resource. So here the constraint is pretty obvious. It's this one where we can make 17 packs per hour. And you can see that we're only using it 60% of the time. So this was a machine that was being run 3 out of 5 days a week. And there were some reasons for that. So how can we change this? And the issues that were blocking us from doing that is they didn't have enough resources to run the machine daily. There was some maintenance that they needed to do, and they didn't have the capacity to clear the line based on the output of the machine. So now that we knew that this is what's holding us back in a way that everybody could understand and get behind, we wanted to subordinate all the other resources to that decision to exploit. So our most important thing was make sure that we operate this at 100%. And then elevate it. So here's what we did. We had a material buffer in front of that constraint so that it would always run. It would never be running dry because there's no material. Make sure that we maximize the uptime by staggering the service, add an inspection table and lighting, update our model so that it would schedule in that form, and added 1 FTE. So once we did all of these, we had protection for a continuous machine operation. We know the machine was always running because it was maintained. Had the line clearance, better planning and scheduling, and the people to run it. So here's the change. That gave us a 66% increase in weekly output using the 3 days a week as the baseline. And we could make 480 packs per week, which puts us over the future demand. Now, there's a strategic decision in here from our perspective as far as making sure that we stock up because there's other elements in the market that we wanted to protect for. And we solved the persistent backorder issue. We have this new process of how we're going to do tactical reconciliation, and we've trained everybody on it. And here you can see what took place. So this is our stock. We made the changes, and now we're starting to stock up in accordance to our strategy. So that was pretty good, and it was something that didn't take that long to do. I think it took us about maybe 2 to 3 weeks, 4 weeks to put it into place. So that was a good win for us. And then the next thing that we're going to do is, okay, now that we know how to do this and that we've gone through this process for one of our simpler product lines, how do we apply it to the core of our business? Most of our products are made in what's called a clean room. So it's a sterile environment. It's a controlled environment where all the products are mixed. And I mean, you could think of it as we're taking different powders and we're mixing them with liquids and we're dispensing them into bottles and vials. That's basically the nature of what we do. And
But it's way harder than that.
yeah, well, I mean,
Way harder than that.
yes, like at a gross level, that was happening. If you look at it through a microscope, it's fairly complicated. So, we took this approach to that and started to say, okay, what's our constraint when you look at the clean room itself? What is the thing that is limiting how much we can make? And there's a lot of interesting things in place there because it's a limited space. It's difficult to expand. It's not easy to qualify. You can't really increase capacity in a short time frame, right? So it's a significant thing to do. But just by changing how we put things through that particular space and how we sequence the operations, we're able to identify a potential 30% gain. And we've started to develop the changes to our policies and procedures to be able to put this into play. And we'll be able to do this with no additional investment. So once we have that, we can get into modeling projections and strategic recommendations. And this is a pretty exciting part for us. As you saw in the beginning of the presentation, we've been growing 20% per year. And every year it gets more difficult because 20% is a lot more than what it was the year before. So how do we know what's coming? How do we know how it's going to affect us? And how can we plan for it? And this is where we're starting to use the APM model, which is a pretty interesting addition for us. So we take R plus or market projections and DVR, and we combine them, and we can come up with a DDMRP-based capacity plan. So the interesting thing here is that we can get, by feeding R plus a forecast or a best expectation of what the future will be, we can get the projected demand signals from a DDMRP perspective with the DDMRP timing, based on how we've set our buffers, right? So our initial attempts have been straightforward. We just take the current ADU and we extend it. Maybe we put a growth factor in it for the 20% growth year over year. And we have all our plan adjustment factors for seasonality. So once that goes into place, we bring it into Excel and we merge it with the DVR routings. And what you see here is this red bar was just the current week. Everything here is historical, so it allows us to see the hourly load by week. And then we can see moving forward what it's been. So the historical piece is useful to calibrate the model and make sure that what it's giving us is in line with what we have experienced. We have the work order count as well. And then over here, there's a couple of weeks where the clean room is going to shut down, so we need to do something about this. All this demand somehow has to be pulled forward or something has to happen. And this dark blue is we're changing the ERP at that time. So again, how do we make sure that we plan for these things and take appropriate action now rather than be in reactive mode later on? So here we're talking about once we have this, what can we use this for, right? So we can evaluate our projection versus our actuals and qualify our model, as I was mentioning. It helps us improve the accuracy of our model. Like this is definitely very motivating for management to see. When they get a better perspective into the future, people become more interested in capturing relevant information in the present. So to the point of that tactical reconciliation, when people start to get information that helps them make decisions, they see the value in capturing it. And it kind of helps strengthen the resolve to follow that process. Helps us improve our routings, helps improve the quality of our forecast because they start to have additional value. And we can make better midterm decisions and have better visibility on when and how to adjust the plan. So where are we after we've been going through this journey for a few years? So we're always remodeling and getting better. There's some products that are working exactly the way that we want them to. There's some that aren't, and we still have some work to do with them. We have some tricky things like have a 3-month run with variable output week to week, and the product that they're making has variable concentration, so how do you measure it? There's all kinds of little tricky things that we feel keep us engaged and working, so this is pretty fun. There's gaps in these ones, as I mentioned, mostly for modeling and data, and it's getting better. And with the newest ERP implementation, I think we'll make a lot of improvements there. And this last one, there's a variety of business models that we have that often requiring us to get creative with modeling. And it doesn't always end up with something that is easy to do from the perspective of transacting. But over time, you can always work on improving that, right? And that's sort of what we've been doing. So the next one is just a few quotes from people. So, we sent out a note to a group there and said, we're presenting at a conference. We'd like some perspectives from people, right? And this is just basically what came out of them saying right away, right? So this is from one of the manufacturing managers. So they were pretty happy about getting the routings in place. It helped them get started with the recipes for SAP. she's happy about transitioning to daily scheduling. And again, she's, the system itself doesn't do exactly what we need it to do, but we've never met a system that does. And the good thing about this one is that we have the ability to keep working to make it do that, right? So this is from QC. They're pretty happy about using DVR in conjunction with SAP to prioritize the work properly. And again, she's mentioning some of the limitations, not real time. And that's more on us as an organization and to the level of detail that we've defined or model. And there's always people want it real time, but when it comes time to transact, we don't always want to do the transactions, right? So where's that tipping point of value in capturing the information versus using it? Partially responsible for improving the metric to testing on plan, so that improved significantly. And she's mentioning partially responsible because there's a lot of things that they did on their end. They changed the training of their people. They changed some of the processes that they were following. But what this do is provide visibility and put the framework in place for them to measure it. This is a new person that just came on board with us. She has a product line where they're shipping primary cells to customers. So it's pretty much live human tissue for experimentation, and it's pretty tricky to manage. And she was doing all of this in Google Sheets and Excel files, and didn't really have a good way to track what she was doing. So she's pretty excited, and she's dropped her Excel sheet. She actually adopted it really quickly and got to what we call Workbench Zero, which is no outstanding priorities in R Plus in about a month. The bigger win for QC was have a trigger to perform their work. Before, again, as Geoffrey was mentioned, people would be working over email, phone calls, meetings, just a lot of coordination. From QA's perspective, it's happy to get more capacity, prioritizing the work. They still manage some releases outside DVR, and now that they got brought into this, and she's a key person in the SAP implementation, they're bringing them together, and they be able to do all the releases coming from DVR. So that's been a very positive thing as well. So in general, I think people have seen the value of the system. It's brought people together, but there are still perspectives that need to be reconciled, right? So to Chad's point on the divisive political climate, it's not that divided, but people have different approaches to how you make something better. And how do you do that, right? So for us, the answer is you gotta stay committed. You have to be clear on what the message is. You have to have a very clear objective and understand why you're driving towards it, why it's the right thing to do. Make sure that everybody understands it. They know how they can contribute to it, and give them a system that supports that. So that's where we are. And questions?
Questions for Juan and Dr. I have one. I'm Hayden from Caterpillar.
Yes.
And greatly interested to understand how you use the DDMRP to generate a signal to your suppliers and how they use that signal.
To our suppliers, well, I mean, like basically what we do is we have our ERP system, and then we have a middleware between our ERP and our Plus. Okay. So I'll go back to that slide here. I mean, I'll have to go back a fair bit, but let's see. We animated the slides by creating, different graphics, so it takes a while.
World class.
Yeah. Okay, here we go. Here. So we have this middleware that is basically making the communication between R Plus and DVR, and that's loading all the data, where we're in inventory, where we're in supply, where we're in demand, and then inside the ERP, the planners generate the orders that go out to the suppliers.
Okay, so you're using an existing
Yeah.
system to do that.
Yeah, basically we broke out the planning and scheduling pieces from ERP, and that's happening in R Plus and DVR. So they still perform those functions inside the ERP system, but the planning and the scheduling is happening inside R Plus and DVR. And the boundary is very clear and very clean, right? So that makes it really easy.
Good. Thank you.
Yeah.
Other questions?
Yes?
So what sort of supplier development did you have to go through I'm guessing there was a fundamental shift of an execution signal to your supply base versus the long-term planning material purchase.
Sorry, how do you mean supplier development?
So, did you have to go to your supply base and say, we're changing the way we're planning, trust us, we're gonna go do a pilot? Did you have to do some change management with your supply base?
There wasn't too much of that. Like a lot of the materials that we buy are like strategic in nature. So there's some materials that we buy, and this is one of the interesting things from a variability and modeling perspective. So you can take a particular material, and I mean, let's just say salt, just to make it generic. But you can have salt, and salt is salt, right? Well, not quite. You can take salt and you can test it and see if it works for a particular application, and it happens to work. So we buy that complete batch and we store it because we know that we can make our product with that one. And we keep bringing in different batches of salt until we find another one that works. So there's no real way to qualify the material based on its characteristics. You have to actually test it and see if it's going to work. And when we find it, we store it. So we invest strategically in inventory from that perspective, right? All this biological variability on some of our low-level raw materials is pretty significant to our business, and we need to make sure that we have sufficient inventory of those. So from that perspective, our suppliers are somewhat isolated from the changes in our supply chain. Where it's changing significantly is on how we cut our manufacturing signals, what's the lead time of the manufactured products that we make. So it's mostly internal. Yeah.
Other questions? I don't remember exactly how many SKUs you had up there, but did you run modeling for every SKU?
Yeah. So we have 4,000 plus, yeah.
Okay, 4,000. And then on your finished goods inventories, did you plug in those part numbers?
Absolutely, yeah. Every last one of them, yeah. So I mean, the simulation file really came from Eric. He gave us the base file, and it was a really good start. And there was one of the planners that's been there for a while now. It had just started, and when she first came in, we're like, well, just gotta punch in this part and punch in the buffer and write down the results and see how you do. And she came back a week later, and it's like, well, I've done like 200 parts, and it's like, oh yeah, keep going. We're gonna get there, right? Yeah. And so it's like, and you kind of say you're gonna get there, and she leaves, and you're like, oh man, we're never gonna get there. Like you're just kind of like, but you gotta put a brave face, right? So we came up with a way to automate that simulation.
Okay.
And now what we do is we load all the historical demand. We punch in all the parts that we want to run through the file. We set the targeted service levels by part class. So we have categories of parts A, B, C, D, E. And they're basically based on relative volume of sales. And we say, okay, for A's and B's, it must be 98%. You set it, you hit run, let it run for a couple of hours, and you have your output.
Is that something you generated yourselves? Or
Yeah.
It's a set of macros, right?
Yeah, it's just an Excel macro. Yeah.
Same simulation logic, but you can tick through and then keep finding which profile is going to fit that part's unique dynamic, and that's how it determines here's the recommended profile.
does that fit into the,
My profile?
the auto buffer?
I think the topic of more intelligence and helping determine those buffer profile settings is very much on our agenda from the software standpoint.
Yeah. Yeah, and that's a really interesting direction because we got a lot of help from the perspective, and that's the path that we actually started ourselves. Is like, okay, let's look at the variability on the part. What's the range of the standard deviations, and how big is it, right? And then we said, okay, based on the variability, assign a buffer. But that sort of qualifying the statistics around the part, the descriptive statistics, and assigning a buffer was one way of doing it. The other one was, what happens if I test how a particular buffer would have performed historically, and I pick the one that gives me what I want, right? And again,
What percentage of your items ended up being buffered? As they handled? Make the order.
I think we have probably like, what would you say are?
90% of time buffers.
Yeah.
Really?
Yeah, the majority of them.
As spiky as your demand patterns are.
Yeah.
That's great.
Yeah. I mean, that's one of the interesting things, right? So that's why we put this slide in here. So as you see here, this is basically the simulation. Like, you don't look at it when it's running. Like, when this person was doing manually, she would punch R23, and it would tell her, you get 84%, and this is the simulation result. So there's all her stockouts, right? And then you go, and the scale is changing a little bit on the graph, so it's a little misleading. But she goes to the next one up, and now she's at 86%.
Tell them one odd thing about you, Delwan. You're the only place I've ever been where a bigger batch makes no difference because storage is small and things are growing. You quit when they quit growing. So
Yeah.
they're a very unusual environment.
Yeah, that's a pretty strange thing.
To fit your world. So they are the only environment I've ever seen that.
Like making 5 liters or 50 liters is the same. The only difference is the cost of materials, but labor-wise, somebody's gonna, they're gonna mix it, and somebody's gonna bottle it, and that's it, right? So it's not 5 minutes, okay. Yeah. So, we get this, and then we can make this particular, and to Chad's point of reconciling to a range, right? Like, this is what we get. Is okay. So 44 days of stock out, you want 0, you can get it. It's gonna cost you $8,200 over $4,500. That means that you're going to have 100% service level for this part, or you're going to throw out 4,500, 82 minus 45, whatever that is. You're betting on one of those two outcomes. For us, it's more important to have the service level, and we're willing to eat the scrap, right? However, moving forward, when you look at the slide where we can make lead time changes and actually affect how much inventory we need to carry to meet supply, where is it, this one? We can reduce that difference, right? So instead of going from 45 to 82, maybe it's going from 45 to 5,200. So it gets more cost effective for us to support those high service levels with high variability parts.
Okay, time for one more question. Yes?
It's two questions, but
Wait a minute.
it's very short. The first answer is very short. For how long have you been running DVR, and how have you managed the cultural change that running this requires, like the transactions, the receiving to the buffers?
Mm-hmm.
Have you had any problem with that?
No.
cultural change?
No, we started in April of 18, right? April 18. And I mean, we have really great team. Like manufacturing people are great to work with. They're all about getting things done, and well, they love it. I mean, so long as you can make a clear case of how this is going to help them, yeah.
So the guy doing this didn't have any objections?
No, it's no problems.
But the key is you adopted from the beginning that you would do model reconciliation. That model is always going to keep changing.
Yeah.
Versus do it and gosh, how come we have to do it again?
And you got to stay committed, and you got to have executive support, right? So that definitely helps. Like, there's a clear signal that this is the direction that we're going. Everybody understands. They know that they have the time to get it right. So people are willing to work towards an outcome. So it's not, people don't lose sight of the goal or commitment to it. And we've had great results. Like when Geoffrey started in Europe, I think, what was the service level when you first joined? Like,
78.
yeah, and he got it to 95 in no time, but starting to follow it, right? So people see the results and adopt it, yeah.
Okay. Thank you, Rick.
Thanks, guys.